All right, the next video as we go along here is going to take basically the last two videos and combine them. So the first video was about adding vectors, like our intro to the unit vectors. The part one of this activity from up here is putting them into standard position. This piece right here is asking us to combine those two things. So it says use what you know about moving vectors to standard position and the different methods of adding vectors and illustrate the sum of the two vectors. So let's get started. We're going to start by drawing u and v in standard position. So u is over 3 up 2. So moving u to standard position looks like this. And v is up 3 over 1. So here's v in standard position. And so we've got the standard position step down. Now it says illustrate the sum of the two vectors. So you kind of look over here and you cheat a little bit to the instructions. It says what method of adding vectors is this set up for? Well, by doing this, putting them in the standard form, standard position, you might notice that we're basically we're creating the we're creating this parallelogram method. And so what we do is we get our green and we draw our resulting vector u and v. So there's a resulting vector. So we moved them to standard position, and then we also use parallelogram methods. So which method? I'm not sure what's happening with the screen there. Illustrate the method of adding vectors and write the components of each vector, including the resultant. So now, if we were to do as follows, see if I get room maybe down below to do that, sort of. So it's saying illustrate it by writing the vectors in component form. So u looks like this. U is in 3, 2. So u is 3, 2. V is in component form -1 up 3. So -1, 3. So again, these are just the coordinates of the endpoint for each vector. Now if we did green, u and v. Well, actually what I need to do is this. I can't just call it. I need to label it as a vector. So the vector itself is one big arrow, u plus v. In component form, that gives us over 2, 5. Okay, so step 1, write the components, including the resultant. This is how could you get the components of the resultant without drawing the diagram? So without doing any of this, it's saying, hey, now look at these numbers and tell me what is there a pattern going on? So if we wanted to look at this and say, well, what is u plus v? Well, let's try this. Let's say 3, 2 plus vector. Well, we know that we need to end with 2, 5, and we're adding these vectors. So if you look at the x component of u, and you say, well, we're adding u and v, so maybe let's just add the x components together. So 3 plus -1. Well, let's see, that's 2. And v and u, let's see, all right, let's look at our y component. So 2 is the y component, and 3 is the y component. So 2 plus 3 is 5. And now if we look, 2 over here, same thing. So what we're trying to say is if you get your vectors, no matter how many you have, we start with 2 to make it easy, but if we start with 2 vectors, u and v, and get them in standard position, we'd write them in vector standard form or in component form. If we do those 2 steps, we can now do any operation. We can add them, we can subtract them, we can do whatever we want. So the idea is vector u plus vector v in standard position in component form, we just add the x and y components together and you get your resultant. So I think I'm going to pause there for now at least.